Kia ora whanau, this video is about calculating expected values. So this is an applied probability concept. This video will cover two questions, so let's get straight into it. First question, in a local hospital there are 10,000 births of second babies. So imagine a family who already has a child, and in a local hospital they're giving birth to their second child. The question is, how many of these, the second children, are expected to be girls? So the first thing we need to do is identify what part of the probability tree, is what we need to look at. And I have highlighted that for you there. So two outcomes there. We can either have a family with a girl first and then a girl second, or a boy first and then a girl second. So in terms of the solution, we know that by multiplying across the probability tree, we want to firstly write down the probability for girl, which is 0.6 times 0.6. And we're not done yet, because we need to add to that the probability of the first child being a boy and the second child being a girl, which is 0.4 times 0.6. Multiplying that all together will give you 0.6. So in terms of what we do with the 10,000, take the 10,000, multiply it by 0.6, and we get an answer of 6,000. So 6,000 of the second children are expected to be girls. And that's it. It doesn't get much more complicated than that. We'll do one more example, and then hopefully it would all become clear to you. So question 2, the length of branches from a kahikatea tree plantation is assumed to be normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. A particular kahikatea tree contains 50 branches. How many are expected to be between 1.7 meters and 1.9 meters? There's a diagram for you. Remember, we should always visualize what the normal distribution question is asking us. In terms of the probability, it is calculated in a previous video titled Normal Distribution. But I've put it there for simplicity so we don't go through the working. But if you need to go through the working, please go back to the other video. The probability of a branch being between 1.7 meters and 1.9 meters is 0.4215, or 42.15%. So in terms of applying this probability, there we go, there's a little note there. We're going to multiply our probability 0.4215 by 50. We get an answer of 21.075. Now that's not our final answer, because we can't have 0.75 of a branch. It's not appropriate to round up either, because it just seems too far away, and we're looking for the nearest realistic value here. Okay, so we've got 21 branches. General rule is to round down, guys. And that's it, guys. Thank you for watching.